Welcome to the Slop Temple. We pray this video helps.
You start by prepping hardware and getting a reproducible base. Flash Raspberry Pi OS 64-bit to a 32 GB plus micro SD, boot, enable SSH, and connect to network. This saves time later. Once done, update the OS and install Python 3.11, pip, and Git so you can install packages reliably. Plug in your USB microphone or sound card and speakers. Test audio with a simple AirAccord/Apply check. Make sure you create a dedicated project folder and virtual environment before cloning code. Now you install and configure the assistant stack. Clone a lightweight voice assistant repo or template, create and activate a Python virtual environment, then pip install speech-to-text, TTS, hot word detection, and required networking libraries. Once installed, map ALSA device ID for mic and speaker and test each component separately. Next, wire in API keys or local models and write the core async loop. Hot word detection. Capture audio, send to SDT, run intent handler, generate response, and send to TTS. Test small iterations frequently. Finish by hardening and automating the assistant so it runs reliably. Create a systemd service to launch your virtual environment and assistant at boot, add log rotation, and secure API keys. Optimize responsiveness by using lightweight models, setting 16K Hz sample rate, and tuning audio buffers. This reduces latency. If things go wrong, first test hardware with AirAccord and Apply. Then recheck ALSA device ID and user permissions. Consult logs from systemd for tracebacks. Once stable, iterate on intents and user feedback.
Thanks for watching. Consider subscribing if we helped you.